The AI buildout has a power problem, not in the abstract, not as a forecast 3 years away. Right now, today, in Texas, the state that has positioned itself as the center of the AI infrastructure boom. Data centers and crypto facilities are failing basic grid reliability tests, not capacity tests. Voltage tests, the kind of test that determines whether a facility can stay connected when the grid experiences a routine disturbance. They cannot. That is 3 things worth understanding: what the test actually measures, what happens when facilities fail it, and what it means for the AI expansion story everyone has been told. Start with what nobody is saying clearly enough. AI data centers are not behaving like industrial loads. A factory, when grid voltage dips for a fraction of a second during a fault, typically stays connected. The equipment was built for an imperfect electrical world. Data centers are different. Server farms, hyperscale compute clusters, and GPU-dense training facilities house sensitive electronics that require near-ideal electrical conditions. When voltage dips, even briefly, even during a fault that is successfully cleared without interrupting service, the protection systems inside these facilities respond automatically. They disconnect instantly, without warning. And when a facility drawing hundreds of megawatts disconnects from the grid in under a second, the grid does not interpret that as a normal shutdown. It experiences a sudden loss of load. The system, which was balanced against that demand, now has generation in excess of what the load can absorb. Frequency and voltage spike. Operators have to respond in real time to prevent that imbalance from cascading into a wider failure. Reuters reported on June 5, 2026, that 4 groups of unnamed large electricity users, including data centers, abruptly disconnected from the Texas grid during a test of how they would handle routine voltage disturbances. ERCOT, the Electric Reliability Council of Texas, released a report dated May 21 documenting those failures. ERCOT reviewed roughly 20 gigawatts of large customers seeking to connect to the system, including 8 projects totaling nearly 9 gigawatts aiming to start up before July 1st. Among that pool, ERCOT identified 4 groups that could each trigger more than 5,000 megawatts of abrupt demand loss under certain fault conditions, 5,000 megawatts per group. Reuters noted that figure is comparable to the electricity consumption of an entire large city like Boston. Each group, not combined. This is not the first time ERCOT has logged this pattern. Since 2023, ERCOT has identified at least 26 events in which data centers or crypto mining facilities abruptly disconnected from the grid during electrical disturbances. The precedent goes back further. In December 2022, a failed transformer at a substation in West Texas caused nearly 400 crypto miners, data centers, and oil and gas facilities to unplug without warning. According to Reuters, the resulting mass disconnection produced a surplus of nearly 1,700 megawatts, roughly 5% of the grid's total demand at the time, and forced 112 megawatts of power generation to shut down. That was from a single substation failure. The scenario ERCOT is now modeling involves not one facility, but entire interconnected groups. ERCOT has said that voltage ride-through failures have become a top priority for its board. Here is what makes that statement worth stopping on. ERCOT is not just managing demand. It is managing the speed and unpredictability of how that demand behaves. A power plant going offline follows a ramp. A large data center cluster going offline follows a cliff. The problem is not contained to Texas. NERC, the North American Electric Reliability Corporation, issued a Level 3 alert in May 2026, its most serious class, specifically targeting computational load behavior on the bulk power system. NERC documented a January 2025 incident in the Eastern Interconnection, where a 230 kilovolt transmission line fault coincided with roughly 1,500 megawatts of customer-initiated load reduction from data center-type facilities. The event remained manageable, but NERC described it as exposing larger planning gaps. The concern is that rapid load disconnection creates the opposite problem from a generator trip. Instead of too little generation, operators suddenly face too much. NERC stated that current planning models and operating procedures may not fully capture how these facilities behave during disturbances. That Level 3 alert-directed transmission planners and grid operators to collect more granular operational and electrical performance data from computational loads and to conduct annual stability studies with explicit load drop contingencies. NERC is simultaneously developing mandatory reliability standards under Project 2026-02, with a standard authorization request posted April 1, 2026. Those standards are not yet in force. Right now, there are no specific voltage ride-through reliability standards for large loads anywhere in the country. What does that mean structurally for the AI expansion story? 3 benchmarks clarify the scale of what is happening. Bloomberg reported on June 4, 2026 that PJM Interconnection, the largest power grid in the United States, serving 67 million people across 13 states, is now facing breakup pressure from federal officials and state governors because AI data center demand has driven wholesale power prices up 76% in the first quarter of 2026 compared to the prior year. PJM's own CEO has publicly stated the current structure is not tenable. Second, capacity costs in PJM's most recent auction rose by almost 400%. The data center boom has added roughly $23 billion to the cost of securing grid supply for the 3 years ending mid-2028, according to PJM's independent market monitor. Third, McKinsey analysis projects U.S. data center electricity consumption reaching roughly 6.5% of total national demand in 2026, and climbing toward nearly 12% by 2030. The infrastructure beneath that trajectory is now visibly under stress. The political dimension has arrived faster than most observers expected. Pennsylvania has threatened to pull out of PJM. American Electric Power, one of the largest utilities in PJM territory, has threatened to leave the organization. President Trump joined several state governors in calling for tech companies to pay directly for the new power plants their facilities require through long-term capacity contracts. A FERC meeting is scheduled for July 23 to discuss structural reforms. Maryland's governor, at PJM's annual meeting in May, said there is no clear plan by PJM to address both affordability and reliability at the same time. That is the political dimension. But the underlying problem is physical, not political. There is a reasonable counter-argument here. ERCOT and regulators have been moving. ERCOT is advancing a proposed rule change, NOGRR 282, that would establish frequency and voltage ride-through requirements specifically for large electronic loads, including AI data centers and hyperscale compute facilities. ERCOT's Reliability and Operations Subcommittee approved that measure in April 2026, ahead of potential board endorsement and regulatory ratification by July. So the framework is being built. That matters. Voltage ride-through is an engineering problem with engineering solutions. Some companies are already testing and demonstrating compliance under the draft requirements. The technology to make data centers grid-compatible exists. What the Texas test failures reveal is the gap between where the build-out is moving and where the standards currently stand. Roughly 20 gigawatts of new large load projects are seeking Texas grid connections right now. The ride-through rules are not yet mandatory. 8 projects totaling nearly 3. 9 gigawatts were aiming to connect before July 1st of this year. Some of those projects were part of the group ERCOT flagged. The timeline for regulatory finalization and the timeline for commercial operation are not aligned. That misalignment is the actual risk, not a distant scenario, not a forecast. It is in the queue today. There is also a financing implication that tends to get overlooked. If mandatory ride-through standards are ratified and existing facilities are required to retrofit their electrical protection systems, the cost burden falls back on operators, and in some cases, on ratepayers. PJM's Market Monitor has already documented billions in capacity costs being distributed across residential electricity customers. The expansion of AI infrastructure is not moving through the grid as a clean, neutral technical exercise. It is moving through markets, regulatory agencies, and utility rate structures in ways that affect people who have never heard of voltage ride-through. What the Reuters reporting surfaces is something the narrative around AI infrastructure spending has consistently underweighted. The bottleneck is not just how much power AI needs. It is whether the facilities consuming that power are designed to behave as responsible participants in the grid they depend on. Right now, in the state leading the build-out, a significant portion of the new load cannot pass a basic stability test. ERCOT knows it. NERC knows it. Regulators are moving, but the projects are moving faster. Watch what happens at ERCOT's board meeting in June. And watch whether FERC's July 23rd session produces enforceable reform or another study period. Those two dates will tell you more about the actual pace of this reckoning than any hyperscaler's announced capacity number. The infrastructure story is real. So is the infrastructure gap. Facts over fear.